So let's take a few minutes and talk about some of the really important basic properties of logarithms. And again, I'm going to continue to note this right here, that the functions f of x equals logarithm base a of x, and the inverse function of that would be a to the x, right? These are inverses, and if you remember something about those, they do have significant interaction because one always undoes the other, right? Remember, we are saying that y equals the logarithm base a of x is true if and only if, and here's my abbreviation, by the way, for if and only if and only if a raised to the power y is equal to x. And as you can see, these two functions, they undo one another, so they're inverses. Now we'll talk more about that, but here's some properties. Number one, it doesn't matter what our base is, right? Well, it does matter that our base must be greater than 0 and not equal to 1, right? Because that's a couple of important points that we developed when we talked about exponential functions. Well, if we say the logarithm base a of 1 is equal to 0, well, it should stand to reason. Why, you might ask? Well, simply because 1 is the result of taking a base that's greater than 0 and not equal to 1 and raising it to the 0th power. Likewise, if I took the logarithm base a of a, I should get 1. And again, this should make some sense because a is the result of raising a base to the first power. Now, this next property, which is a helpful one, tells us that the logarithm base a of a to the x is equal to x. Well, yes, because that is an inverse function relationship. In other words, the logarithm base a undoes a to the x and gives us x. And we actually went through an example about this before. You know, we had said, and I'll just put a little asterisk right here. We had said earlier at one point that if I had take, for example, the logarithm base 2 of 32, that I was going to get 5. And I knew that I would get that because 2 to the 5th is 32. Well, in a sense, this is like rewriting this expression, saying let's take the logarithm base 2 of 2 raised to the 5th power. The result? Well, it is 5. These two things undo one another. So this is an inverse property, an inverse function property. And likewise, a raised to the logarithm base a of x will also give us x because these two functions, they undo one another. So it is important to realize these two things. And we'll come back to this in an example below. There's one more property that we want to know. It says that if the logarithm base a of x is equal to the logarithm base a of y, then x is equal to y. This is important because remember, it's inverse functions. All inverse functions are what we call one-to-one. And one-to-one functions are the kind of functions that say that, well, if you take the function, apply it to one value, you take that same function, apply it to the other, it's only as true when these two values are equal to one another. So logarithm base a of x is equal to logarithm base a of y. Well, how could we use these? Here's an example. Let's say we're told to solve the equation, simple equation, logarithm base 3 of x minus 1 is equal to logarithm base 3 of 4. Well, by that property, this can only be true if and only if x minus 1 is equal to 4. And the reason why? Well, whatever the logarithm base 3 of 4 is, it has to be true for both numbers, and it's only true if, in this case, x would equal 5. So that we would have the logarithm base 3 of 4 is equal to itself. It's a one-to-one function. All right, well, let's go back to our inverse properties. If I said the logarithm base 2 of 2 to the x plus 1, well, if you're using this as a model, you know, then that means that the result should just be x plus 1. The logarithm base 2 and the exponent base 2 undo one another. And consequently, if I said the base 5, and I raise that to the logarithm base 5 of t, we're essentially saying, well, to what power must I raise the base 5 to get the number t? And if I take that exponent, raise 5 to it, Oh, I'm going to get t. As a result, they undo one another. And so in this case, we can use these one-to-one properties and these other properties to help us discover more about these particular logarithmic functions. Okay, more to come.